In this video, I'm going to work through a couple of examples of how we use reference angles to find values of trigonometric functions. So in this first example, we've got an angle of 150 degrees. So let's first try to get a picture of what this angle looks like. So if I draw my x and y axes, 150 degrees is a positive rotation, which means we're going to start rotating counterclockwise. We always start our rotations along the positive x-axis, so I'm starting at 0 degrees, and I'm going counterclockwise. Now an entire circle is 360 degrees, so every quarter turn is going to be 90 degrees. So if I rotate up to the positive y-axis, that's going to be 90 degrees. But my angle is 150, so that means I need to keep going beyond 90 degrees. If I go halfway around my circle, that takes me to 180 degrees, and that's too far. So that means that my angle 150 is somewhere in between 90 and 180. I'm not going to worry too much about trying to draw this super accurately. I'm just going to try to make sure that I end up in the right quadrant. So that's my 150 degree rotation. Now, the reference angle is always formed between the terminal side of my angle. That terminal side is that red line that I drew coming out of the origin, and the x-axis. It's always formed with the x-axis, never the y-axis. So the angle that I'm looking at for my reference angle is this green angle in here. That's what we often call alpha. So how many degrees is that? Well, 150 degrees gets me rotated around to this line that I drew. And so if I went further to 180 degrees, that's 30 degrees more. And so that's what alpha is. Alpha is 30 degrees. So how does that help? What that helps with is it tells me, since I know what the sine of 30 degrees and the cosine of 30 degrees are, those are nice angles that we already know the sine and cosine of. We worked through that in a previous lesson. I know that the sine of 30 degrees is 1/2, and the cosine of 30 degrees is radical 3/2. What that tells me is that the sine of theta, this angle 150 degrees, is either plus or minus 1/2. And the cosine of theta, right, not 30 degrees, but theta is plus or minus radical 3/2. Now, how do I tell whether it's plus or minus? For that, I figure out what quadrant I'm in. I'm over here in quadrant 2. And so in quadrant 2, x is negative in quadrant 2, and y is positive in quadrant 2. So in quadrant 2, x is negative and y is positive. How does that help? Well, I know that sine of theta is y over r. The radius of this circle, now I don't know what the radius of this circle is, but I do know that the radius, whatever it is positive. And then the y-coordinate is also positive. And so that's a positive divided by a positive. And so that means that in quadrant 2, the sine of my theta is going to be positive 1/2. But the cosine of theta is defined to be x over r. Again, I don't know what x and r are, right? I don't know what my radius is, but I do know that the x is going to be a negative number, and the radius is always positive. And so that means that the cosine of this theta, this 150 degrees, is going to be a negative number, so it's going to be negative radical 3/2. So that's how we use reference angles. So when I say use reference angles to find these values, that's what we're doing. The reference angle is the values up here, and then our angle that we're looking at is either plus or minus those reference angle values, and the way we figure out whether it's plus or minus is by using the quadrant. All right, so this last question says, consider the circle of radius 12 centered at the origin. Using your answer to part B, we want to find the coordinates of the point on this circle corresponding to our angle theta. So this tells us that our radius is 12, right? R equals 12. And so sine of theta is y over r, and that's equal to 1/2. Since r is 12, that tells me y over 12 equals 1/2. Multiply both sides by 12, that's going to get me y equals 6. Cosine of theta, that's x over r, and so that means that x over r is negative radical 3/2. Or in other words, x over 12 is negative radical 3/2. Multiply both sides by 12 there, I get x equals negative 6 times the square root of 3. And so those are my x and y coordinates on this circle. So once we know what r is, we can figure out x and y based on the sine and cosine. In part B, we didn't know what r was, we just knew that it had to be positive, and that's how we figured out the sine and cosine. So hopefully all the steps there are making some sense to you. All right, let's do a similar example. So no circle in this one, but again, the difference here is that we're dealing with an angle in radians. So finding the reference angle, same basic idea. So I'm going to try to draw this angle. It's a positive rotation, and we always start our rotations on the positive x-axis. Now, because I'm rotating in radians, I'm going to use radians as my guideposts on my axes. So 1/4 turn here is going to be pi over 2 radians. Now, my fraction has a 3 on the bottom, and pi over 2 has a 2 on the bottom. So my common denominator is going to be 6, 2 times 3. So I'm going to rewrite 4 pi over 3 as 8 pi over 6, multiplying top and bottom by 2. And pi over 2, I'm going to write that as 3 pi over 6, multiplying top and bottom by 3. That helps me understand whether or not I've rotated far enough. So if I go to the positive y-axis, if I rotate this far, I have not gone far enough. I need to go 8 pi over 6, I've only gone 3 pi over 6. If I do a half turn, if I rotate around to there, now that's going to take me to pi, which I can also write as 6 pi over 6. I need to go 8 pi over 6, so that's not far enough. So I need to keep going past 6 pi over 6. If I go all the way down here to my negative y-axis, that's 3 pi over 2, also known as 9 pi over 6. That's too far. So my angle is somewhere in between 6 pi over 6 and 9 pi over 6 is going to be somewhere around to there, taking me into quadrant 3. Now, what's my reference angle? My reference angle is always formed between my terminal side of my angle and the x-axis. So my reference angle is going to be in here. How far is that? Well, 6 pi over 6 took me to my negative x-axis. 6 pi over 6 took me to here, but I have to go a little bit further to get to my 8 pi over 6. So how much further did I have to go? Well, 8 pi over 6 minus 6 pi over 6 is 2 pi over 6, also known as pi over 3. And so that's my reference angle, that's my alpha. How does that help? Well, now I figure out the sine and cosine of that pi over 3. We've got a little chart that we've memorized that tell us what the sine and cosine of these nice angles are, and pi over 3 is one of my nice angles. Sine of pi over 3 is square root of 3 over 2, cosine of pi over 3 is 1/2. So that means that the sine of this angle, the sine of 4 pi over 3, is plus or minus square root of 3 over 2. And the cosine of this angle that I was worrying about, the theta, is plus or minus 1/2. So which is it, plus or minus? Well, in quadrant 3, x and y are both negative. Now, I don't know what x and y are. I don't have enough information in this problem to figure out x and y, but I do know that they have to be negative numbers. Sine of 4 pi over 3 is y divided by r. So that's going to be a negative number divided by a positive number. So that means that the sine of 4 pi over 3 is negative radical 3 over 2. And cosine of 4 pi over 3, well, cosine of any angle is going to be x over r. X is negative, so that's a negative divided by a positive. So my cosine of 4 pi over 3 is negative 1/2. But the problem is asking me for secant and cotangent, not sine and cosine. But now I can use my sine and cosine identities to rewrite secant and cotangent in terms of sine and cosine. The secant of this angle theta is 1 divided by the cosine of theta. So that's 1 divided by negative 1/2, which simplifies to be negative 2. And the cotangent of theta is cosine of theta divided by sine of theta. That's going to be my negative 1/2 divided by negative radical 3 over 2. I can multiply top and bottom by 2 to get rid of those fractions within my fractions. So that's going to be negative 1 divided by negative square root of 3. And that simplifies to 1 divided by the square root of 3. So the process here is draw your picture, figure out what your reference angle is, use that reference angle to find sine and cosine, and then use those sine and cosine values to find any other trig functions that you're looking for. So I hope this video helped walking through the steps. Feel free to replay this video multiple times if you need to see the steps again as you're working through similar problems, and I'll see you back in class.